Hello everyone. In this video, I will be going over questions 11 through 20 on the practice final for MAT1033. Number 11, we want to factor the following completely. We have 4y squared plus 23y minus 35. We want to factor this completely. Now, unfortunately, there's not something in common we can factor out of everything. What I mean by that is the 4, the 23, and the 35 don't have something in common that we can take out and make the numbers simpler. So that's not helpful. What we have to do to factor this is use the AC method. And there's a lot of ways to do this. You probably developed your own way. I would encourage you to do it your own way, but if you've forgotten, you can do the way I'm going to do. The AC method pretty much starts off by saying, I want to multiply A, which is 4, times C, which is negative 35. And don't forget the negative there. And that is negative 140. Now, what do we want to do with that? We want two numbers that multiply to this. And I also want them to add to positive 23. Now, what two numbers are those? Well, it might take some time to figure out because you have to think about factors of 140. Well, 140 is 14 and 10. That won't work. What are some other factors? Well, let's think also, it's a number ending in a 0. So we can do 140 is 5 times something, and that something is 28. And that's perfect. Why is that perfect? Well, because they multiply to negative 140, one of these has to be negative. If I make the 5 negative, then negative 5 times 28 is negative 140, and negative 5 plus 28 is the positive 23. So our answer for that question is negative 5 and 28. All right, now, a lot of AC methods start off like this as well. You figure out these two numbers and then you branch off and do it your own way. I do it the factor by grouping way. So what it's going to look like is we take our 4y squared and we replace the 23y with negative 5y plus 28y. And then the minus 35 at the end. So pretty much what we did, all that work, was to figure out how to rewrite the 23y. All right, but why did we do that? Well, now you can factor this by grouping. And once again, this is a review, so it should sound familiar to you. We factor by grouping. We group the first two things together and the last two things together. In the first two things, what is in common? Only a y is in common. 4 and 5 have nothing in common. When we factor the y, we get 4y minus 5. What about this second pair of things? 28y and negative 35 don't have a y in common, but 28 and 35 you can both take a 7 out of. So let's do that. And when we take a 7 out, we get 4y minus 5. Once you're here, you're actually almost done because the number or the thing inside the parentheses is one of your factors, 4y minus 5. The other factor, that's the stuff on the outside. We have y plus 7. And that's our answer. What is number 11, this thing factor to? 4y plus 5, minus 5 times y plus 7. Once again, I know there's a lot of ways. You may have another way to do it, but this is my way because it always works and you don't have to guess and check. Number 12 says solve 0 is less than 5x minus 1, which is less than or equal to 2. So what you want to remember here is when you have inequalities that are all less than or equal to like this strung together, you can work them both at the same time. We want to get this x by itself. The first thing to do is add 1 everywhere. Right? So we want to add 1 to get rid of that 1, but we also have to add 1 on both sides of the inequality. We have to add it over here at the 0 and over here at the 2. When we do that, we got 0 plus 1 is 1, is less than, now 5x is just the inside, which is less than or equal to 2 plus 1, which is 3. Okay, so we've done that. How do we now get x from 5x? We divide it by 5. Because we're dividing by a positive number, everything's fine. We just divide everything by 5 in a similar way. So the 5's cancel out, and we're left with 1 over 5 on the left is less than just x in the middle, which is less than or equal to 3 over 5. Now this is the compound inequality. Notice it wants two ways. This is called the compound inequality, which is great. So we're pretty much done with that part. What about the number or the interval notation? Well, interval notation comes when you make a number line. That's probably the easiest way to do it. If you go ahead and draw a number line out, and you mark off these two numbers. So we got 1 over 5 and 3 over 5. What this is saying is x is between these two. So I'm going to shade in the area between these two, but I have to be careful because the 1 over 5 does not have an equal sign on it. So that gets just a parentheses or an open circle. The 3 over 5 has an equal part to it, so it gets a bracket or a closed circle. And when I write that in interval notation, if I use parentheses and brackets, it makes it a lot easier because I do a parentheses on the 1/5, and then I do a bracket on the 3/5. But that is our interval notation, and we can check both. We see our compound inequality matches, and we see our interval notation also matches. We're good to go. All right, what about 13? 13 is another inequality, but it's an OR, so we have to do them separately. It says to give your answer in interval notation, so it's not going to ask for compound. We have 4x minus 7 is greater than negative 31, or negative 2x plus 3 is greater than or equal to 19. All right, so let's go ahead and solve them. You have to do these completely separately. Do the first one over here. We add the 7 to each side. When we do that, we've got 4x is greater than negative 31 plus 7 is negative 24. And then to get the x by itself, we divide by 4. But because 4 is positive, nothing happens. Our inequality stays the same. We get x is greater than negative 24 over 4. That simplifies 6. We got negative 6. Now remember, this is an OR. But when we write our answer, this is going to be just part of it. And now we want to do the other inequality. Negative 2x plus 3 is greater than or equal to 19. We subtract the 3 from each side. We get negative 2x is greater than or equal to 19 minus 3, which is 16. And then to get x by itself, we have to divide by negative 2. And this should be the one thing that goes off in your head. Whenever you multiply or divide by a negative number, the inequality flips. So what we're going to have is we're going to get x because the negative 2's go away, but this is going to switch to less than or equal to. It's going to face the other way. And 16 over negative 2 is negative 8. All right, so we have our two inequalities and we need to make interval notation out of it. Well, go ahead and mark off the two numbers we have here. We have negative 6 and negative 8. Negative 8 is smaller. Make sure you go ahead and do that in the correct order. And we just want to shade in everything correctly. X is greater than negative 6 means we want a parentheses on negative 6. Greater than means we go to the right. And there's nothing stopping us from going to the right forever. So this goes all the way to infinity. What about the other one? Well, this one gets a bracket because it's an equal sign on the inequality. And it's less than, which means it's going to be to the left because we want smaller numbers. It's going to include that interval. Now, how do we write this in interval notation? Well, we take the left inequality. It goes all the way back from negative infinity, which automatically gets parentheses, goes up to negative 8, which we just discovered has a bracket. When we have another interval here, we do a union, and then the -6 has a parentheses, and that goes all the way to infinity, never stopping. So our answer looks like that. And I can click on the answer here to show you everything works out. Now, you should know how to do this from before, but if you are a little shaky, remember you can click on the interval. It'll have all the setups for you with the infinities and everything, and the union symbol is right here when you type it in. Don't type in the letter U, you have to use this symbol right here. Right, number 14. Number 14 is just a graph, so I'm going to do it all on the graph here. We've got to graph y is greater than or equal to 1/2 x plus 1. Well, but when you start this one off, the thing to remember is that it's an inequality. You have to choose whether the line should be solid or dashed. Because there's an equal part on the inequality, we want the solid one. So I'm going to choose this one. If I chose this one, I would automatically be wrong. All right, so we got this one. Now, how do we start drawing graphs? Well, we first graph the y-intercept, which is at 1. We go ahead and just put a point there. Now, the slope being 1/2, that tells us the top is the y number change and the bottom is the x number change. So this is saying if I go up 1 in y, so if I move up 1 to here, I'm going to go to the right 2. So if I move up 1, from 1 to 2, I'm going to go right 2. So I'm going to go all the way from 0 to 2, put my other point. And now the last question is, which side do I shade in? This can be the kind of tricky part, and this might be the part where you want to go ahead and do some work. I'm going to go ahead and just explain it on the right over here. Which side to shade? Well, what I like to do, you can pick any point at all that's not on the line. I like to pick the origin if it's not on the line, which it's not, so 0, 0. What I want to do is plug in x equals 0 and y equals 0 to the inequality, the equation we have. I want to plug it in here, and I want to know, is it true or false? So go ahead and take this equation and replace y with 0. We get 0 is greater than or equal to 1/2. Replace x with 0 as well, plus 1. And then 1/2 times 0, anything times 0 is 0. So this is just 0 is greater than or equal to 0 plus 1 is 1. Is that true? Is 0 greater than or equal to 1? No. What is that telling us? It's telling us to shade in the side without 0, 0. If we got a yes, then we would shade in this side because it's where 0, 0 is. We don't want to shade in this side, so I just pick any point over here, click it, and it will shade in the other side for me. And then I can submit, and you can see that we get it right. But if you do all that work, let me just plot the 2 points, and you randomly guess which side to shade in. So let's say I just randomly decided to shade in this side. I didn't really put any effort to it. It would not be correct. So do not do that. You don't even get partial credit. 15? 15 is another calculator question. It says simplify the answer completely. Now it is partially a calculator question, but it also should be done by hand because you want your final answer to be a fraction. All right, so there's two things to do here. One is you never want to use negative exponents if you can avoid it, and we can easily avoid it. We can make the exponent positive by doing what? By flipping the fraction. Okay, so because it's -2, it's going to become 2, and we just flip the fraction inside. 2 over 5 becomes 5 over 2. Now what we can do from here is we can distribute the exponent because we have division or multiplication. Division in this case. Well, on the top we got 5 to the 2 power over the bottom we have 2 to the 2 power. And each one of these hopefully you can do by hand, but if not, just check it in your calculator. 5 squared is 25. 2 squared is 4. And that's actually it. That is a simplified fraction. Go ahead and click on it. It says the answer is 25 over 4, which this system may not reduce completely when shown here. So this is fully reduced 25 over 4. All right, number 16. Forgot to label this as number 15. Number 16. Give the slope for each graph. If there is no slope, type D and E for does not exist. Now, what you want to remember here for the slope is that if we have a horizontal line like this, the slope is automatically 0. Horizontal lines have 0 slope. It is important you understand, though, that 0 slope is not no slope. When I type in 0 here, I'm not typing in D and E. Vertical lines have no slope. And that's the second one. So it's kind of hard to wrap your head around that beginning because we think of 0 as this number that represents nothing, but it's really representing 0. And so a horizontal line has 0 slope. A vertical line is D and E. Go ahead and hit enter so you can see it works. Now these are all set up the same way. So if I did do D and E for this horizontal line, which has 0 slope, you'll see that it marks it wrong because D and E and 0 are different. So just be aware of that. This should be 0, as we showed already. And this one is D and E. All right, number 17. Number 17 is one of those old scientific notation problems. We got 9.13 times 10 to the 26 over 1.1 times 10 to the 13th power. Now, how do we do this? Well, there's a couple ways to do it. Some calculators are very nice in the fact that what you can do is just type them in scientific notation and it will give you out in scientific notation. But that's not every calculator. What your calculator can do is it can simplify the 9.13 over the 1.1 part. So go ahead and type that in your calculator. 9.13 divided by 1.1, we get 8.3. That works perfectly out to 8.3. Now what about the other part? Times 10 to the what? Well, the exponent rules tell you to subtract the top minus the bottom. So times 10 to the 26 minus 13 power. And 26 minus 13 is 13. So we get 8.3 times 10 to the 13th power. We can go ahead and check that. And we see that works perfectly. Okay. Number 18. Go ahead and box that in. Number 18 here. Says let f of x equals 5x minus 6 over 2x minus 9. Find the domain in interval notation. All right. So remember the domain when you have a fraction is you set the denominator equal to 0. So what we have in our denominator is 2x minus 9. I don't care about the numerator at all. Only the denominator. 2x minus 9 equals 0. Solve this. We got to add 9 on each side, we get 2x equals 9. And then we divide each side by 2. And we get x equals 9 over 2. Now, how do we use this? Our answer isn't 9 over 2. The domain is everything except 9 over 2. Right? Because what we just did, we figured out what number makes the denominator 0, and that's not allowed because you cannot divide by 0. How do we draw that to convert it to interval notation? Because that's what we want. Well, what I'd like to do is go ahead and make a number line with that number, 9 over 2. Because I want to include everything except this, I put an open circle on this because I'm not including it, but I include everything to the left and everything to the right. Now, how do I write that in interval notation? Well, the left portion starts way back at negative infinity, goes all the way up to 9 over 2, And we have an open circle, which means we use a parentheses. But we also have another interval to the right of 9/2. We union. And then when we hop over this circle here, we're still at 9/2, but it's not being included as well. We have a parentheses on the 9/2, and it goes all the way to infinity. The way to read this is that we want to include everything except 9/2. And you can see that that's exactly what we have here. All right, number 19. Number 19 asks you to solve each equation and determine how many solutions each has. And the first one we have is 8 times negative 8x minus 1, and then plus 2 equals negative 61x minus 9. All right, so let's go ahead and solve. Got to distribute the 8 through. We got negative 64x minus 8 plus 2 equals negative 61x minus 9. This is very similar to, I think it was the very first problem in the practice test. We just have to do 3 times and then answer it slightly differently. We want to gather the x's on one side. I can add the 64x to each side. And then I also want this 9 to be on the other side, so I can add 9 to the other side as well. And what are we left with? On the left, we have negative 8 plus 2 plus 9. That's just 3 equals negative 61x plus 64x is 3x. And then I can divide each side by 3 to get the x by itself, and you get x equals 1. Well, how many solutions does this have? We have one answer, so there's one solution. And that would be exactly what we get for the first part. Now, what about the second one? Let's go ahead and do that. We got negative 9 parentheses negative 6x minus 7 minus 5 equals 54x plus 63. Distribute the negative 9 through. We're pretty much going to do the same exact steps. We have negative 9 times negative 6 is positive 54, 54x. And then negative 9 times negative 7 is positive 63. Then we have this minus 5 equals 54x plus 63. Do the same thing as last time. Get the x's on one side. I can subtract the 54x over to the right. And I can also subtract the 63 to the left. Well, what's happening here, you probably recognize that there's a lot in common and almost everything's going away. We wanted to cancel that 54x out, but it also cancels out over here. We wanted to cancel out the 63 on the right, but it also cancels out on the left. Well, everything canceled out on the right side, which means there's actually 0. On the left side, we still have negative 5. And does 0 equal negative 5? No, that means there is no solutions. So notice that the x's are all gone. When the x's are all gone, you're just going to have a number on each side. If the number's different, then there's no solutions. And you can see we got that. And then the last part, we got 8 parentheses negative 5x plus 2, then minus 1 equals negative 40x plus 15. Same steps, just distribute the 8 through. 8 times negative 5 is negative 40, so we get negative 40x. 8 times 2 is 16 minus 1 equals negative 40x plus 15. And you might notice a similar thing to the last one already. If you don't, go ahead and start gathering. We want this 40x to go to the right side. We want this 15 to go away from the x, so we subtract it. And now with this one, the 40x's happen to go away on each side. The 15's gone over here. We have 0 on the right side. What about the left? 16 minus 1 minus 15, that's also 0. And what happens when we get 0 equals 0? That is when there is infinitely many solutions. Infinitely many solutions or infinite solutions. As you can see with the answer choice, that's it. And the three possible answer choices are exactly what we got here. Yeah, those are the three possibilities you have to look out for. All right, number 20. Number 20 here we have using the square root property solve this. We've got 3x squared minus 15 equals 0. Okay, the square root property is one of the new things. It is when we get the x by itself, or specifically get the x squared by itself, because there's only an x squared, there's not an x. So let's go ahead and do that first. We want to get this by itself. We can add the 15 to each side. We get 3x squared equals 15. Once again, I'll just box in the x squared because that's what we're trying to get by itself. What do we have to do now? Well, if we divide by the 3, then it will be by itself. And we get x squared equals 15 over 3, which is 5. Now, how do we finish up? The square root property tells us to do the square root of each side, but when we square root, we have to plus or minus. Right, the square root knocks out the squared, which is why we do that. So we just have x. And then the plus or minus gives us two answers. We have plus the square root of 5 and minus or negative square root of 5. Now, typically we don't write the plus because it's already a positive number. So I'm going to go ahead and just get rid of it. And those are our two answers. You can't simplify the square root of 5, which means that's it. And you can see if we click on the answer, we have exactly those two things. All right, so that's question 11 through 20. In the next video, I will do questions 21 through 30.